today's session on edge computing and IoT edge platforms. We are delighted to have you all join us virtually for another insightful session. Before we proceed, let us begin with an invocation to seek blessings for wisdom and knowledge. I now invite Mrs. B.S. Fibula Dani, Assistant Professor, PG Department of Computer Science, to lead us in prayer.
Let's all go down for prayer. Loving Heavenly Father, we come to you this hour asking for your blessings and prayer as we are gathered together in the third day of 5 days FTP on edge computing and IoT edge platforms. Pour your blessings upon our founder, Father, and Chairman, Reverend Father Dr. J.E. Arulraj, Administrator, Reverend Sister M. Baby, Principal Dr. R. Ruben, our today's person, the resource person, and on all the faculties of various institutions. May this FTP will be an effective learning tool for all of us who have joined in the session. We give this entire FTP into your mighty hands. We ask this prayer in the name of our Lord Jesus Christ.
Thank you, ma'am. To welcome our esteemed gathering, I now invite Dr. M.G. Tangamma, Assistant Professor, Department of Computer Science, to deliver welcome remarks.
A very good afternoon to all, and a warm welcome to all assembled here for the 5 days scientific program. I extend a gracious welcome to the inaugural ceremony of the MVP. It's my pleasure to welcome our administrator, Reverend Sister Dr. M. Baby, and our principal Dr. Ruben, who continuously supporting us to conduct various meetings and seminars, and I extend my welcome to our today's resource person, Mr. Mahesh, Assistant Professor, Department of Computer Science, Apollo Arts and Science College, Chennai. I welcome our beloved HOD who organized the 5 day faculty program. I am extremely happy in welcoming all other HODs and faculty members of our college from various colleges. I extend my welcome to program coordinators and technical team. Finally, on behalf of BCA Department, PG Department of Computer Science, once again, I welcome you all. Thank you.
Thank you, ma'am, for your warm welcome. It's now time to introduce our distinguished resource person for today's session. I request Mrs. V.A.S. Mohan Lakshmi, Assistant Professor, PG Department of Computer Science, to introduce our esteemed speaker.
Good afternoon. It's my pleasure to introduce today resource person Mr. K. Mahesh, Assistant Professor, Department of Computer Science, Apollo Arts and Science at Chennai. She has completed an MCA at Jaya Engineering College. She is specialized in cloud computing, operating system, cryptography, etc. She has various technical skills like creating web applications using JSP Server, JDBC, and MySQL, and acting as an advisor and trainer to train students for their academic work. She got certification in warehouse management and Tech Mahindra Foundation and Java programming at SLA. He completed his internship in various technical schools like media at S Foundation Bangalore for 2 months and special education internship in NIE PMD Muttukadu for 2 weeks. He got General Proficiency Award in Pattison College of Arts and Science. He started his career as a relationship manager training at India Foundation, moved to Trained Technical Quants and Verbal VIT Well, then moved as programmer in Rosen School of Business and Technology, now currently working as assistant professor at Apollo Arts and Science College. Once again, welcome sir.
Thank you, ma'am.
Thank you, ma'am.
Now, as we delve into the core of today's session, I'm pleased to invite our resource person, Mr. Magesh, to take over the session. Sir? Sir? Magesh sir.
Welcome you all. Welcome to this FTP on Edge Computing. The title of the FTP is Edge Computing and a IoT Edge Platform. In this, okay. In this FTP, we are going to cover the following topics. First, introduction to edge computing building blocks, edge computing for IoT, advantages of edge computing. Okay. Evolution of cloud. Four different concepts are related with each other, right? And which are linked with the cloud. So we have introduced the cloud first. The classical cloud provides the concept of a virtual machines, which is IaaS, infrastructure as a service. The VM running on the remote data center, that is offered in a remote data center using the technology which is called virtualization, a storage that was offered by the remote data center. Then we have also seen that this virtual machine will get replaced by containers, and more workload moving towards the container just to allow IoT passes. Third, third important concept we have seen around the development of cloud towards the distributed cloud with the help of a technology which is called edge computing. And therefore, using this edge, data is processed locally, and the computation comes more closer to the device or the source of data generation that is an edge. And the topic of today's this particular FTP. Okay. Edge also has an advantage of applying A&M, artificial intelligence, and machine learning, which was the de facto standards for cloud computing for the artificial intelligence and machine learning. So, cloud is now used to train the models, whereas the inferences is to be carried on the edge, also called the inference layer. So let us describe this de facto, the maybe a tech or a protocol widely used even though it is not accepted in a certain fandom, that is what is called as de facto standards. So we go ahead and understand about the So we move on to introduction to edge computing. Introduction to edge computing are the five major key points here. First, edge computing allows the cloud to be genuinely distributed. In contrast to that, what we have seen that the cloud was highly centralized and all the resources are classified as are being defined as client-server architecture, right? Where the cloud becomes the server. In that architecture, cloud is highly centralized here. The technology, edge computing, which allows this cloud to be distributed, and we will see how that particular edge will provide this type of motion into the cloud computing. Therefore, this second important, this edge computing do not rely on the cloud for all purposes, right? For example, data aggregation, collection, processing, and querying. All can be done at the edge. Hence, this particular notion is now take away. And with the edge computing, the cloud can become more distributed, right? Earlier, cloud used to do it, but now can be done at the edge. That is, for example, processing, data aggregation, collection, querying. Let me see how the edge computer will mimic the cloud functionalities. So therefore, the important aspects of edge computing is that it will mimics the public cloud platform capabilities. One second. So we are going to see more details about how these activities, which are earlier done by the cloud, now also can be as well done by the edge. Now there will be a choice for the application, which one to choose and which has the more advantages, whether edge or a cloud. The fourth important points about the edge computing introduction is that it reduces the latency. How? By avoiding this round trip. When you see a round trip, you mean you have to understand that the device and the cloud. You have a device and a cloud. So this device has to send data to the cloud for doing the computation. And after the computation is finished, the result has to come back to the device. For example, if I'm sending a certain messages to someone, one device to another device, I'm sending a request to the device and getting a response from that. This delay and this particular aspects of round trip time will introduce a sufficient amount of delay, and this delay can be reduced. Another layer, which is in this diagram, another layer which is called as edge is introduced. In between your devices and the cloud, edge is introduced to delay that round trip time, to reduce the round trip time. So that's what we reduce the latency by avoiding round trip and bringing in the data sovereignty by keeping data where it's actually belongs. Edge computing will relieve this particular, for example, RTT, round trip time, to a very little minimum. Why? Because this edge is very close to the device. Therefore, it will reduce the latency. It will reduce the latency, and it will also avoid the round trip to the cloud and bring it to the data sovereignty by keeping the data where it actually belongs. Uh, I guess everyone know about data sovereignty is an important concept in the security. For example, consider government organization or let us say hospitals or some personal data. Sometimes people don't want that just to be sent to the cloud. They have the fear, right? That personal identification or personal data will be disclosed. Therefore, to protect this data sovereignty, you have to keep the data where it's belong, that is at the source itself. And edge computing will protect this kind of data sovereignty by not sending to the cloud yet. All the computation, for example, all the computations can be performed very close to the source. That is at the location where the data is generated. Um, because in previous, what we do is we are sending some data, the cloud will store the all the do all the computation work and send back to us. Whereas in edge computing will protect these kind of data sovereignty by not sending to the cloud. All the computation can be performed very close to the source. So that is at the location where the data is generated. If I'm, for example, imagine one device on the cloud. Previously, we are sending a data to the cloud and getting all this data. All this computation works done in the cloud. In between, we are inserting an edge. The edge will it will reduce the time period, right? Compute all the works and send back to the devices. Finally, the edge computing introduction also talks about how the edge computing will deliver the local storage, compute, and the network services. Earlier, in a high centralized manner, the cloud used to give, right? The edge will also doing or mimics the public cloud capabilities, and that is what is about the edge computing. We are going to see how these capabilities are going to be given to the edge computing. Okay. Edge computing makes distributed cloud because cloud do this type of heavy jobs. But how the edge computing makes the cloud truly distributed. The current cloud, or rather the previous generation of cloud, was almost like the mainframe or like a client server, the client side, but all the heavy lifting was done by the cloud. Okay. Because cloud do this type of heavy jobs, but how the edge computing will make this kind of architecture, which only cloud can do as a server, how these functionality can be shifted away from the cloud, and yet all the computation can be performed by the edge computing. We can see through this particular diagram, right? There is a cloud. Below the cloud, you can find an edge. Below the cloud, you can find the edge. So edge node also has the capabilities of storage and computation. And if it is done at the edge, then no need of sending the entire computation to the cloud. So edge node also has the capability of storage and computation. Then it is not needed to be sending entire computation to the cloud. Therefore, so cloud is no longer be the client server architecture. Therefore, with the introduction of the edge and the cloud, it becomes truly distributed. Okay. With all the innovation in the hardware chips and with affordable electronics and silicons, it makes more sense to bring compute down to the last mile and actually keep the compute closer to the device. So that means these capabilities are now possible to bring into the edge because of the innovation in the hardware, and also affordable to provide large number of edge nodes and making this compute very close to the device and making this particular cloud a truly distributed one. So that when edge computing becomes more and more viable, where you know you don't need to rely on the cloud for all the processing and queuing. Instead, you could actually run a computing layer that is very close to the device. What are the processing data we are doing, right? Aggregation, collection, processing, and encoding. Instead, you can also run a computing layer which is very close to the device, which is called the edge. So we can see that this is a imagine the device on the cloud, where earlier device used to send all the data to the cloud. Uh, now they don't have to send directly to the cloud. They can send to the edge, and the edge can respond with all the computation back to the device. This is quite close to the source devices where all the data is generated or very close to the device. So edge computing makes the cloud truly distributed. So um, second introduction to edge computing. Edge computing mimics the public cloud capabilities and move cloud service closer to data source. The edge computing mimics the public cloud platform capabilities. You can see here this the cloud, whether the central cloud. Check this diagram. Cloud, central cloud, whether the central cloud or regional cloud, and this is the capabilities which is being created very close to the source, and this is called edge. So if you go in detail about the capabilities which are to be required to become an edge computing. For example, when you dissect an edge computing platform, you would notice that it almost has all the capabilities of typical public cloud. So that means when you deselect an edge computing platform, so let us have the contrast that public cloud versus edge computing. So what are the capabilities which public cloud has now, being also capable into the edge layer? That is what edge computing. That is what edge computing we are talking about now. Why this is needed is to support the IoT pass. So IoT, as you know, that the device management requirements earlier Earlier, cloud used to do it. It has the data injection in the cloud. Earlier, it has a stream analytics in the cloud. Earlier, to support the IoT pass, and it can be run the machine learning models into the cloud very well, and it can also run the serverless function into the cloud. So, are all these capabilities that are predominantly available in the public cloud. Four. But with edge computing, they are come to the last mile delivery point and run very close to the source of the data, which is sensor, actuator, and devices. When you talk about the source, which is generating the data, that is nothing that is nothing but a device. So, as I told you, the devices means the sensor which generate the data. Yeah, the sensor which generate the data and the actuator which consumes the data. Both of them are called the devices, and if this computation is very close to the device, that means the capability of cloud that is provided to the edge, then all the advantage and new application is possible. That is what is. We have to understand here by means of the edge computing. Here, the sensor which generate the data and actuator which consumes the data. Both of them are called the devices, and if this computation is very close to the devices, that means the capabilities of the cloud, if it is provided to the edge, then all the advantages and new application is possible. Uh, Third, edge computing reduces the latency by avoiding round trip and bring in the data sovereignty. First, the biggest advantage of deploying an edge computing layer is that it reduces the latency by avoiding the round trip. It also brings in the data sovereignty by keeping data where it's actually belongs to. So this is not the small thing. This is the huge specifications, right? This is the huge specifications which allows many applications which were not ready or willing to be performed into the cloud with the help of this edge computing. Now it is possible and very easy because of avoiding the round trip time and reducing the latency supporting various applications. For example, in a healthcare scenario, it may not be viable or may not be compliant to actually stream sensitive patient data to the cloud, where it is getting stored and processed, insists that patient data should remain on premises within hospital premises, but it still need to go through a lot of processing and find out very useful insight. So in that case, the edge computing layer is going to stay close to the healthcare equipment with connectivity back to the cloud, and the architects and the customer engineer will decide what data will stay within the edge boundary and and what is moved to the cloud may be anonymous data. So the data from the devices are now being processed by the edge layer, and the data need not have to travel to the cloud. Therefore, the time can be avoided here in this particular place because we are sending uh, only the selected data to the cloud. Other than that, all the computation works done in between the devices and the cloud. We have the edge computing. All this computation is done by the edge and sent back to the hospital premises or devices. Yeah. Uh, is that time delay from between edge computing and cloud computing because we are sending all the data to the cloud and getting a computation from the cloud computing, it's take a delay, right? Latency. Whereas in edge computing, we have in between right in the cloud, we are reducing the latency. Yeah, we are reduces the latency. Edge computing building blocks. Okay. We are going to move to the next discussion. We have completed the introduction to edge computing. We are going to move to the next discussion that is about the edge computing building blocks. The capabilities which are now added also in the edge, which was earlier also done by the cloud. So the first capabilities is called data injections. M2M brokers, machine to machine brokers, object storage, function as a service, NoSQL, real-time database, stream processing, machine learning models. These are some of the basic building blocks which can be performed at the edge and which was earlier the capability of a cloud. So this will mimics the public cloud capabilities. Well, let us see one by one. Let us see one by one. That's how these building blocks, how they are to be supported by the edge layer. So the first one is called data integration, data injection. Sorry, data injection is the endpoint for getting the source data, which comes to the high velocity, high throughput data endpoint, such as Kafka. What is that Kafka? Everyone know about this? Kafka is a free open source software platform for storing, processing, and analyzing data stream in real time. So, such kind of data injection tools and techniques or capabilities was with the cloud, but now these kind of capabilities are now allowed at the edge. So the particular data injection will going to inject the data, which become the high throughput data endpoint at the edge itself. Second, it is a process of obtaining and importing data for immediate use or storage in a database. To inject something is to take something in or observe something. Data can be streamed in real time or inject in batches. The first is data injection. Kindly check the diagram of data injection. These are the sources, right? Batches, real-time streaming. The first source is called a batch. Batch means the data which is injected will be stored somewhere into the databases. The second source of the data is to be real time. So data which comes as a stream, which will be captured by the data injection or to be computed or to be processed without storage. And therefore, this streaming data becomes essential building block for real-time analytics. For example, the sensor data which is monitored a particular temperature of a machine, whether it is very hot or whether it is a very hot or not. So all the time the data is being generated and the real-time analytics has to be done. In this sensor data, which is monitoring a particular temperature of a machine, whether it get very hot or not. So all the time the data is being generated and the real-time analytics has to be done. It cannot be stored. It cannot be stored like a batch processing, um, and can be stored data, and then it can happen later. So in the real-time data injection, each data item is imported. Each data item is imported as a source. As a source emits, so there are many examples which these kind of data injections which are done by the tools like Kafka. I already told Kafka is a free open source software platform for storing, processing, and analyzing data stream in real time. Like Kafka, which was only been performed by the cloud, now has become the building blocks for in the edge computing. So it can support these kind of data injection technologies. Okay. Another edge computing building blocks is in the terms of mission to mission broker, M2M, mission to mission broker. Edge will also run message brokers that will orchestrate mission to mission communication. For example, device 1 talk to device 2 via the mission to mission broker. And now earlier these kind of mission to mission brokers, these kind of mission to mission brokers were supported by the cloud. Now it can be other basic building blocks of edge computing as well. Check, check this diagram. They are sending directly to the cloud. Each of them is performed by edge computing. So they become the basic building blocks for edge computing. Of course, MQTT is a backend system which coordinate messages between the different clients. responsibilities of the brokers, which includes receiving and filtering the messages, identifying a client, and sending them to the message. Now, another basic building blocks of edge computing is the storage. So, the storage, sometimes the cloud storage, we also call it as a object storage. There may be unstructured storage, particularly to store the feed from a video camera and mics, and everything that is unstructured will go into the object storage. Okay, explain this. Now, these kind of objective storage also can happen on edge, which was earlier only been performed by the cloud. The technology for doing this is NoSQL and time series databases. More structured data goes into time series database and NoSQL database. So it can also support unstructured data. So yeah, here you can see the example that structured data and unstructured data, diagrammatic representation of structured and unstructured data. In unstructured data is qualitative data in the form of text files, audio files, video files. Whereas structured data is a quantitative in the form of numbers and values. Okay. So both type of storage is now also available at the edge as a building blocks, which was earlier being done only at the cloud. I hope everyone is aware of there are two main type of data, right? Uh, Qualitative and quantitative data. Quantitative data is provided in a numerical form. For example, weight, volume, or cost of an item. For example, 10 rupees, 16, 50 kg. These are the things called quantitative data. The qualitative data is descriptive, like the name, place name. These are the things which come under qualitative data. Now, another basic building blocks for is computing, stream processing. It is a complex event processing engine that is enabling you to perform real-time queries and process the data as it comes. In show the diagram, it will be easy for you. So you can see that the data is coming in the form of stream, just like you see the water stream. So this particular data, which requires real-time stream processing to perform the real-time queries, has to be carried out by earlier in the cloud. And the stream processing engine, now it can run as the capabilities have grown into the edge computing. So therefore, these kind of technology, that is stream processing technology, are also included as a basic building blocks in the edge computing. For example, for every data point, you need to convert Fahrenheit to Celsius or Celsius to Fahrenheit, or you want to convert the timestamp from one format to another. You, you could do it in stream processing on the fly in a real time. So that's the major advantage of stream processing. So that's why we consider the stream processing as a basic building blocks for edge computing. Because each and every time real-time queries has to be carried out. Uh, Now it has the capabilities to run into the edge computing. So therefore, these kind of techniques, that is stream computing technology, are also included in edge computing as a basic building blocks. Yeah, we see, right? These all this conversion can be done on the fly in the real time. Another important building blocks of edge computing is function as a service. To add additional business logic, there is a function as a service which is actually responsible for running lightweight computer. If you need to do more sophisticated code, you could actually move that to function as a service. So, for example, that if you have a business intelligence in place, you want to apply when the data is being computed or being received at the time. So, therefore, functions as a service can be applied as a business intelligence, and this is also possible to be done at the edge computing. Because in cloud computing, which is divided as a client server architecture. Okay. Next building blocks of edge computing is machine learning models. Nowadays, machine learning models okay, machine learning models. So machine learning models is there is a machine learning runtime for example, most of the computing platform are capable or running the TensorFlow or later Cafe model, so that you can actually process the data when it comes in for more intelligently and to take the preventive measure and makes the performs the cloud earlier. Yeah. Now these kind of techniques or platform like TensorFlow, Cap model Pi, all this model which supports can also be done at the edge computing. Check this is the input one, processing, and the output one. So what complex it is, it can deal with it and gives the output in a fraction of seconds. IoT and edge computing. Um the Internet of Things refers to a system or interrelated internet connected objects that are able to collect and transfer data over a wireless network without human intervention. In IoT, with the help of edge computing, intelligence move to the edge. There are various scenarios where speed and high-speed data are the main components for management. power issue, analytics, and real-time need help to process data with edge computing and IoT. Whereas IoT edge computing is we can process data near the source of data generation instead of sending it to the cloud or data center, which helps to reduce latency and improve real-time decision making. Whereas how does it work? Means edge computing bring processing capability or the sources of the data, maybe a device, which means having less computation and storage in the cloud, and instead moving to local place such as an edge server. Not all IoT devices are necessary at the edge. IoT devices can connect to the cloud. IoT devices can connect to the cloud or data center for processing, whereas edge edge devices perform only the computation locally. They can perform the computation locally. Whereas in sensors and device communicate with real-time data to a network. They solve latency issues associated with the cloud. They solve latency issues associated with the cloud, and also the data is processed closer to the point of its origin. Oh. Advantages of edge computing. There are some I mentioned few advantages. For example, speed. We already discussed. It reduces the latency when prevention. Uh, because everyone has a fear if the cloud disclosed or our personal identification or personal details. So here in edge computing, all the computation are done and sent back to the devices. So it has much security than a cloud. Because edge computing will protect the data sovereignty by not sending to the cloud. All the computation can be performed very close to the source itself. That is at the location where the data is generated, right? So we can reduce the data theft and data sovereignty, these sort of the things, because it is an important concept in security. Because people don't want data to be sent to the cloud. They have the fear that personal identification or personal data will be disclosed. So in edge computing, we are very secure when compared to them. So once again, I'll highlight the advantages of edge computing: speed, security, scalability, reliability, cost effectiveness, cost saving, advanced security, data loss prevention. We already know security. We already discussed with that. Faster data process, because faster response time. Edge computing can improve the fastest response time by processing data closer to the user. So we can get a faster data processing. Whereas in security, we can improve the data privacy by processing data on premises, because we are processing all the computation work on the observable. It reduce latency. Edge computing can reduce latency by processing data closer to the user. And also in to a conjunction, edge computing bandwidth, reducing a traffic cost effectiveness. Okay. Why edge computing is cost effective means due to the ability to reduce the bandwidth cost by processing data locally near its source, because it's minimize the transmission large amount of data to the central cloud, therefore lowering the overall infrastructures and network usage expenses. So because many of them have the doubt, why it is, do you think it is cost effective? So it can reduces the bandwidth by processing data near to the sources, because we are not transmitting all the large amount of data to the central cloud. We are lowering the network usage expenses, and managing a distributed network can be highly compared to traditional cloud computing. Uh, Edge computing is very promising and has found many useful applications. Edge computing gained notice with the rise of IoT and the sudden glut of data such devices produced. But with IoT technology still in relative infancy, the evolution of IoT devices will also have an impact on the future development of edge computing. Because, for example, self-drive car, uh, sensors, cameras, these are still in research because many of them which lead to malfunctions. These are the things will going on that. Anyway, IoT is still in relative infancy. The evolution of IoT devices will have to impact the future development of edge computing. And we have some applications, right? Real-time machine learning are there to production errors. In the manufacturing, in a production error, we can use edge computing. Even also in the farming to track the water usage, nutrient nutrient density, and also the effect of the environmental factor. And we will produce some good yield, right? Whereas in the healthcare industry, has drastically expanded the amount of patient data collection from devices, sensors, and other medical equipment. The enormous data volume requires edge computing to apply automation and machine learning to access the data. Because one of the example we discussed on introduction to edge computing, that hospital example, because only the required amount of patient's details we are sending to the cloud. Other than other than that, all the computations works are done by the edge computing itself, because it has a, for example, in a CCTV camera, in a traditional cloud storage means on the cloud server, the video output for all the camera is put to the motion detection application. Clip featuring activities are to the server database. This means there is a infrastructure. As significant get consumed by the higher volume, the video footage being transferred. Whereas in edge computing, the motion sensor computation is moved to the network edge. So each camera uses its own internet computer to run the motion detecting application and then send footage to the cloud server if needed. The result is a significant reduction in bandwidth uses, because much of the camera footage will never have to travel to the cloud server. If it is any doubted or a malfunction inside this, it will send to the cloud. Other than that, it will delete on itself. Okay, if you have any doubts, you can ask. Am I audible?
Yes, sir, audible.
Okay. If you have any doubts, you can ask.
Participants, you can ask your doubts. Thank you, sir. Thank you so much for such an insightful and enriching session on edge
Uh,
computing and IoT edge platforms. Your
uh,
presentation has truly broadened our understanding.
I
The
majorly
integration,
focus on the building blocks, man, because that's why many of them thinking they have to understand the building blocks first. Even IoT applications and platforms, they can implement in easy manner if they understand the building blocks means. And I actually thanks to HOD man, right? St. Joseph College, Lakshmi ma'am, and the fellow assistant professor who introduced me to the HOD ma'am, Yamini and Priyadarshini ma'am. I'm really thankful for them, and I'm thankful for my HOD Sagaya Shubhashini ma'am and my fellow colleagues. Thank you, ma'am.
thank you, sir. Your
Hmm, thank
presentation has truly broadened our understanding. The integration of IoT with edge platforms is undoubtedly shaping the future of smart application. Once again, we thank you, sir. Dear
you. Yeah,
faculties,
yes,
I
sir.
request you all to turn on your
Thank
video
you.
so that we can make a memorable photo. Dear faculties, please turn on your video. Thank you everyone for your cooperation. As we come to the conclusion of this session, it's time to express our gratitude. I now invite Mrs. M. Mahadevi, Assistant Professor, PG Department of Computer Science, to deliver the vote of thanks.
I extended my sincere gratitude to our esteemed founder, Father Dr. J. Nagaraj, for his continuous support. A special thanks to today resource person, Mr. K. Magesh, Assistant Professor, Department of Computer Science, Apollo Arts and Science College, for sharing valuable information for edge computing. My heartfelt thanks to our administrative sister, Dr. M. Devi, and our beloved principal, Dr. R. Ruben, for encouraging us throughout the planning and execution of the event. Next, I thank all the participants who graciously support us and enrich the discussion. Finally, I extend my gratitude to all the HODs, program coordinators, faculties, and technical teams. Thank you all.
Thank you, ma'am. Thank you all. Kindly use the feedback link which is posted in the chat box.